Hello. Hello. I think my voice is audible to all of you, and my computer screen is visible to all of you, right?
Yes, sir.
Okay. Okay. So
Yes, sir.
we resume our class. We are talking about the parallel series and shunt mode. Okay. I think all of you can understand this. The next you you see the video carefully, and one by one, line by line, I will describe. Okay. Okay, so I already talked about the parallel connection. Okay, where the field winding is connected with the armature winding of the DC motor in the parallelly, and it is we call this this parallel connection is the shunt motor. When a motor has this parallel connection, then we call the motor is a shunt motor. And when a field winding of the DC motor connected with the armature winding in series, then we call it a series connection motor. Also, there will be compound motor is there, where series and parallel connection both will present there. Okay. Okay, so now we talk about the what is the now we talk about the what is the characteristics of this particular motor. Every motor have every in the DC motor also the series shunt and the compound motor they all have the various type of characteristics. That's why we are using these motors are in the various way. Okay, like in the series motor, you can in the series motor. This is the series motor. Okay, series in the series we connected the circuit here. Okay, you can in the bottom you can clearly see the speed versus torque curve of the DC series motor. In the series motor, you can clearly see the starting torque. In this portion, this indicating the starting. In the starting, the torque is very high. In the starting, the torque is very high. So in the series motor, we have the large amount of starting torque, but the starting torque, large amount of starting torque is there. Where we need to large amount of starting torque, that we will use the DC series motor. Okay, okay, but it main deficit or the negative part is that when the when it going to rotate, the speed is dropped. The speed is dropped drastically. Okay, you can clearly see in the time of starting the torque is very high. But when the time goes, when the motor is running, then the speed is dropped very drastically. This is the very negative part of this DC series motor. You know. Okay, so I am talking about in the DC series motor that the problem is the DC series motor can't have the constant speed. Okay, DC series motor can't have the constant speed. मान लो हमें स्टार्टिंग में कोई बड़ा अमाउंट का टॉर्क चाहिए, कोई चीज को पुल करना है, ऐसा कोई एप्लीकेशन है, तो हम डीसी सीरीज मोटर यूज करेंगे बिकॉज डीसी सीरीज मोटर हैव द लार्ज अमाउंट ऑफ स्टार्टिंग टॉर्क. But when the time goes, then its torque or speed is decreasing slowly. But in the shunt motor, you can clearly see this is the circuit diagram of the DC shunt motor, where shunt motor in the bottom, you can clearly see the torque characteristic of the DC shunt motor. In the shunt motor, the starting torque is not that high, but DC shunt motor, the beauty of the DC shunt motor is it has the constant speed throughout its operation. Okay, it is a constant speed. You can clearly see the speed is near about constant. The speed is near about constant from the graph. You can tell that the speed is near about constant. The starting torque is not much high as the DC series motor, but the speed is constant. This is the one of the benefit of the DC shunt motor. Okay, it does not depend on upon the load. When we apply the load on the DC series motor, then the speed is going to down with the time. But in the shunt motor, it does not change when we changing the load. Okay. Okay, and also DC motor have the back theory. Okay, so we do not discuss about the theory portion very much because our main aim. Mute yourself, Shahil Ali. Okay, so we not discuss about the theory portion. Okay. Okay. Okay, so we have the basic idea. After that, after when we complete the video section, then we discuss about the theory part much more. Okay, now go to the another part, and that is induction machine. Wait, I am opening a video. Okay, now we will discuss about the induction machine. We already discussed about the DC machine, DC motor. I think we all have the basic clear idea, the internal part of the DC motor, how DC motor works, what is the circuit connection, maybe there circuit connection. Okay, now we will going to discuss about the induction motor. Do not worry, after this video session, we will discuss one by one in everything in the theory portion also. Okay, so see the video and I will discuss every part in line by line. Okay. Okay, so this motor is invented by the greatest scientist of the all time in the electrical engineering, that is Nikola Tesla. And this man is I think this man is the god of the electrical engineering. This man invented many things, and the DC is invented by this man. Before when the Nikola Tesla is invented AC. Before that, DC is there, and DC is used money everywhere. But this man is the reason. That's why in the world today we are using the AC. Do you know that in the industry today? Present in the present scenario, 90% we are using induction motor everywhere in the industry or the AC car, like Tesla car. In the Tesla car or the electric car, we are using the induction motor, and all thing is also in the power station. We alternator is there. By the help of the alternator, we generate the electricity. So this man is behind this all the things. This man is the God. You should know about this man also. Okay. Okay. Now come to the induction method. Okay, so I am talking about that 50% of the power consumption of the world is due to the induction motor. इस दुनिया में जितना भी पावर कंजम्पशन होता है उसका 50% is consumed by the induction motor. Okay, and 90% of the industrial motor are induction motor type. 90% of the induction motor, we all use the induction motor in our industry, and the main reason is that one or two point is that induction motor is the very robust. It is maintenance free. It is we can control the speed of the induction motor very easily. Okay, so that is the basic and basic things. That's why we are using the induction motor. Okay, very rapidly. So this is the outer surface of the induction motor. Okay, this is the outer surface of the induction motor. Now we will going to see the inner portion of the induction motor. Okay. So induction motor have the two parts. As I told you guys already that every machine, every motor has two parts. One is stator, one is rotor. You can clearly see one is stator, one is rotor is there. So in the stator part, stator winding is there, and in the rotor part, rotating part is there. Okay. In the rotor, stator winding is there, and rotor part, rotor is there. Okay. Okay, so this you can clearly see in the screen that this in the stator of the induction motor, this is the three coil winding. This is three coil winding in the stator of the induction motor because this is a three-phase induction motor. We supply the three-phase supply 420 volt to this induction motor stator. Okay, if the motor is single phase induction motor, then instead of three phase winding, we single phase winding is there. Okay. Okay, and you can clearly see this is the single phase winding when we are using the single phase induction motor, and this is the material. This is the steel material. This is the steel material. Also, we mix this steel material with the other things like silicon, so that this steel material have the high permeability in its high permeability. Okay, the steel material have high permeability in its, so that when we use the also in the DC motor, you can clearly see we use the slot of the DC motor rotor is high permeable. We make the high permeable because the flux can go with the low reluctance path. That means low reluctance means low resistance path. Like in the current, if we put a resistance, high resistance, if we give, why we are using the copper coil? Because this is the low resistance. This provides the low resistance, so that the current can flow very easily. High conductivity is there, low resistance is there. In the wood, what happened? In the wood or glass, the resistance is more, so that current cannot pass. Same thing happens is also in the magnet also. Magnetic field also. Magnetic field also passes through the low reluctance path. Low reluctance. Resistance is for the electrical circuit and reluctance is for magnetic circuit. So when we pass the magnetic field in the low reluctance path, means low resistance path, then magnetic field can pass or move very easily. That's why we are using this steel that we are also we are this steel mixed with silicon or the other thing which can give the steel to the high permeable path for the flux. Okay. And one is the most important thing, and most important thing and most interesting thing also happens when we give. This is what this is the field winding of the induction motor. When we give a supply like three phase or single phase supply to this field winding of the induction motor, then RMF is produced. RMF means rotating magnetic field. You can clearly see the magnetic field is produced, but the nature of the magnetic field is rotating. It is a very interesting thing. You can clearly see in the video also. The magnetic field is rotating. Okay, when you give supply to the field. Okay. Okay, so I will explain all the thing in the simpler portion. This is the, you can know, this is the if you let it be a three phase winding. Okay. Okay, अगर तुम्हें समझने में कोई प्रॉब्लम हो रहा है तो इधर देखो, the three coil, we put the three coil in such a way 120 degree apart. Okay, three coil we put in the 120 degree apart, and ओके एंड जब ये कॉइल के अंदर से जब करंट पास होगा, ये कॉइल व्हेन द करंट passes through this coil, then what happens, one magnetic field is created, magnetic field is created. Okay, okay, so when a three-phase supply is passing through this special arrangement, okay, so the magnetic field is produced as shown. Okay, okay, so the three phase when we passes, it is nothing but a simpler representation of the field winding. Three phase winding, we put three winding in the three coil in a 120 degree apart, and when we supply the three phase supply to these windings, then what happens? If magnetic field is creating, and you can clearly see the wave is generated by the three phase. Okay, you can clearly see. Okay, R, Y, and P, and the RMF which is produced, rotating magnetic field. The nature of the magnetic field is the rotating. So also there will be a question that what is the synchronous speed? Okay, and also we call the rotating magnetic field that moves in a particular speed, we call it is the synchronous speed, that is represented by this Ns. Okay, and particular formula is there. Okay, now listen to me very carefully. Why? This is the nothing but a field winding where we put the three phase supply and we get the magnetic field. Now if we put a coil in the magnetic field, now we put the coil, it is nothing but a rotor. This coil, the inner coil, this inner coil is representing as a rotor. When we put a coil in this magnetic field, rotating magnetic field, coil means the conductor. When we made a coil with the help of conductor and put it in the rotating magnetic field, then what happens? So because of the rotating magnetic field, listen to me very carefully, because of the rotating magnetic field, the Faraday, according to the Faraday law, one EMF is induced in this coil. One EMF is induced in this coil because this coil is we put the coil in the rotating magnetic field, and this coil is represents nothing but a rotor of the coil. Okay. So, and this EMF which is produced is also the reason for the, after the producing the EMF, a current is flowing, because when EMF is there, then current also flowing. So after the induce the EMF, the current is flowing into this loop. Okay. So now the situation is the nothing but a current carrying loop situated in the magnetic field. A current carrying loop is situated in the magnetic field. Okay. So according to the Lorentz law, पहले क्या हुआ था, पहले इसको पहले बहुत अच्छी तरीके से सुनो मैं क्या बोल रहा हूँ। मैं एक क्वेश्चन आप पूछूंगा तुमसे, जिस क्वेश्चन का आंसर मैं जो बोलूंगा उसके अंदर ही। पहले क्या हुआ, पहले में रोटर में, पहले में स्टेटर है, दिस इज द स्टेटर पार्ट, रिप्रेजेंटिंग द स्टेटर पार्ट। इसमें मैंने 3 कॉइल को 120 के अपार्ट में वाइंडिंग कर दिया, ठीक है। इसे रिप्रेजेंटिंग एज द फील्ड वाइंडिंग। इसमें मैंने 3 फेज सप्लाई दे दिया, पुट द 3 फेज सप्लाई हियर। आफ्टर पुटिंग द 3 फेज सप्लाई, magnetic field is creating, and the nature of the magnetic field is rotating, and the speed of the rotating magnetic field we call the synchronous speed. After that we put a coil, it is represented as a armature or rotor in the magnetic field. Then what happened, according to the according to the Faraday electromagnetic law, when we put the coil conductor in the rotating magnetic field, one EMF is generated. When the EMF is generated in the coil, then current is flowing into the coil. When current is flowing into the coil, then according to the Lorentz law, force is created into the coil. Force is created into the coil. When force is created into the coil, then this coil is moving. This coil is moving. You can see this coil is moving. This coil is moving. Okay, and this same phenomenon happen in the induction machine also. This same principle happen in the induction machine also. Okay, that's why we call the induction machine we call the machine, this machine is the induction machine. Interviewer may be asking why we call the induction machine as we call the induction machine is induction machine. Induction machine को induction machine क्यों बोला जाता है? Why? That is the reason we call the induction machine as the induction machine. Okay. Okay. So one thing you can remember, that in the induction machine we just put the supply to the stator. We did not supply anything in the rotor. But in the DC machine, we supply both stator and rotor, both the circuit in the DC supply. So single phase supply is the using in the induction motor, and we did not supply anything in the rotor. But in the DC machine, we supply both individually, stator and rotor individually. But in the induction motor, we did not supply the rotor that is induced. The rotor is rotating due to the induction. That's why we call the induction machine as the induction machine. Okay. And also we are using this is the squirrel cage induction motor. Okay, this is a squirrel cage induction motor where a squirrel cage, a cage like rotor is shorted, metal is shorted, and put this arrangement into the rotor of the induction machine. Okay, also the slip ring induction motor is there. Okay. Okay, so same thing happens here. This is the rotor of the induction motor. Okay, we did not supply anything in the rotor, we just supply in the stator field winding. When you supply in the field winding, one rotating magnetic field is there. When we put in the rotating magnetic field in a coil or the rotor, हम लोग पहले क्या किए थे, coil को insert किए थे. अभी हम लोग ये coil cage rotor है, इसको हम लोग अगर rotor में अगर place कर देंगे तो क्या होगा? So one EMF is induced. When the EMF is induced, then current is flowing into this rotor arrangement, into this coil cage rotor. Current is flowing. When the current is flowing, into the rotor, then a Lorentz force law is applied, and according to the Lorentz law, a force is applied into the rotor and rotor start moving. You can clearly see rotor is rotating. That's why the motor is called induction motor. Okay, we did not supply the electricity, but due to the induction, it is rotating. Due to the electromagnetic induction. Okay. Now we will discuss about the advantage of the induction motor. The advantage of the induction motor is the nothing but it is a self-starting motor. It is the self-starting motor. Okay. Okay, so you can clearly see that here rotor is two speed is there. That two speed is there. One is the rotor speed, that is the NS, NR. NR is the rotor speed. Rotor speed means this rotor is rotating in how much speed. And NS is the nothing but a synchronous speed, which is the speed of the rotating magnetic field. That is the RMF. So if the rotor speed and synchronous speed both are in the same equal, then what happens? Can anyone tell me what happens? If the rotor speed and the synchronous speed, rotating magnetic field speed, both are in the same, both are same, then what happens? Can anyone tell me? Then motor is does not rotate, because when these both speed are equal, then rotor did not cut anything. Rotor circuit did not cut the magnetic field, and when it did not cut the magnetic field, then the EMF does not induced in the rotor circuit. When the EMF does not induced in the rotor circuit, then current is not flowing. When current is not flowing, then Lorentz law can't apply, or force does not apply on the rotor. So rotor does not rotate. Okay. So always remember one thing, that synchronous speed is always better. Synchronous for the rotation of the motor, synchronous speed must be the greater of the rotor speed. Okay, synchronous speed is must be the greater of the rotor speed, so that the rotor circuit can cut the magnetic field which is produced by the stator, so that the EMF can induce, current can flow, and force can apply on the rotor, and rotor can rotate. Okay. Okay, and the main thing is, one very important thing is that the sleep is the nothing but a difference between the rotor speed and the synchronous speed. The difference of the synchronous speed minus rotor speed is called the sleep. It is a very common question by the interviewer. Can ask you what is the sleep. Sleep is nothing but a synchronous speed minus rotor speed. Then the interviewer can ask you that if the rotor speed and synchronous speed is equal, then what is going to happen? Then you guys said that the answer is that the motor can't rotate, because rotor circuit did not cut the any electromagnetic field flux, so that you can't produce. Okay, and the sleep value is near about 2 to 6%. Okay, so main thing I will not I will now discuss about the why induction motor is so much used. Why induction motor is so much used. So one by one I will discuss. Like in the induction motor, no permanent magnet is there. Like DC motor, in the small DC motor, in the DC motor we using the permanent magnet, but induction motor no permanent magnet is there. So if we put the permanent magnet, then what happens? If we put the permanent magnet, due to the time, the magnetism property of the permanent magnet get loose, and the efficiency of the motor simultaneously can lose. No buses is there. In the DC motor, carbon bus is there. Okay, no bus is there. No commutator ring is there. In the DC motor, commutator ring is there. Okay, no commutator ring is there. The DC motor bus and commutator very very quickly get damaged. Okay, and some flash is there, some hazard may be there. Okay, okay. So this is the that's why this is the also very robust induction motor. Induction motor is a very robust thing. So that's it for today. Next day we will discuss the second part. We will discuss induction machine last part and the synchronous machine. Also we see the theory portion. Okay. Do you have any question? Or otherwise we will end the meeting here. The next part is we will going to discuss this experiment next part in the next class. Do you have any query? Tell me quickly. The Zoom time is ending. Do you have any query? Hello? Can you take the screenshot? Hello? Do you have any query?
No, sir.
Okay, so we will discuss the next part. This experiment is not completed. Next part we will discuss the next class. Okay. Okay. Thank you for today. We will meet next week. Okay. Thank you. Thank you.
Okay, thank you, sir.
Thank you, sir.